Today we're looking at radical addition and subtraction. If you have not yet watched the simplifying radicals video, simplifying square roots in particular, you should definitely do that before attempting this lesson. Just to recap simplifying really quick, remember that we had two options to make that happen. The first method was using factor trees. That's where you could start with your number and break it into any combination of things that will multiply to be that number. So if I start with 50, things that multiply to be 50 are maybe 5 and 10. And then 10 continues to break down into 5 and 2. So we have a group of 2. The group is what dictates what comes outside of that radical symbol, and whatever does not have a group stays on the inside. If you at any point have more than one number in either of those places, they do get multiplied back together. You will see this piece a lot today, where you have an extra number in front of your radical that will get multiplied at the very end to make 40 square roots of 2. To compare that to the other method, this is where we break this down into a little bit more strategically into a perfect square and then some other numbers. So if I start with the square root of 50, 50 could break into 25 and 2, 25 being the perfect square. So the square root of 25 is 5, and the square root of 2 would be a decimal, so that part just stays. Similarly, we have that 8 again, which will come down and multiply on the outside to make our final answer of, again, 40 square roots of 2. Okay, pick your favorite method. You're going to use it a lot today. All right, so radical addition and subtraction is a lot like combining like terms. You are only allowed to combine radicals with the same radicand, so the number underneath of the radical, and the same index. That issue doesn't come up as often, but it would just mean you can only combine square roots with square roots and cube roots with cube roots. So just to kind of compare here, these two radicals you would be allowed to combine. Notice that they both have square roots and they both have a radicand of 5. So these are great. These two are not so good. Although they are both square roots, that number underneath of the radical is not the same. So we would not be allowed to combine those two. Similar deal here, although the radicand is the same, we have a square root and a cube root, so that little index there creates those to not be allowed to be combined. And then last but not least, this one is a-okay. You have two square roots and the same radicand underneath. This number out in the front, I refer to it as a coefficient. I'm not sure if that's official or not. There is a 1 in front of this one, but I would be allowed to combine those things. Similar to all of our other radical lessons, you are not supposed to get decimal answers, but you can use those decimals to help check your work. All right, so here's what has to happen to be able to simplify radicals for radical addition and subtraction. Our first job is going to be to simplify each term. Sometimes you won't have to, sometimes you will, sometimes you'll simplify some parts and not others, just kind of depends on your problem. You can use whichever method you prefer to simplify, so you could use factor trees or perfect squares, whatever you like. Ultimately, what we're trying to get is matching radicands. You should always simplify if you can. You might get a problem where there already has matching radicands, but it might still be too big and still be able to be combined, so you should totally simplify those if they can be simplified. All right, after that, you're going to combine terms with the same radicand. So you're going to think combining like terms. So you're going to add or subtract that front number and your radicand will stay the same. So going back to that 4 square roots of 5 and 3 square roots of 5 for our first example, on this one I don't need to do the simplification step. I already have a couple of matches here. We have square root 5, square root 5. So my only job is to add these front numbers. So if I look at 4 plus 3, that's going to be a 7, and the square root of 5 stays the same. It's almost like saying 4x plus 3x makes 7x. So you can kind of think of it like that. All right, on the second example, it works the same way. Do remember that there is a 1 in front of that other radical, just so that way we make sure we get that right coefficient on here. Again, no need to simplify. We already have square root 7, square root 7. So I can just do 1 plus 8 to get 9. That makes my final answer. More likely than not, you are going to need to do some sort of simplification. So if I look, I don't have matching square roots. So what that means is I should try to simplify one. So 3 won't break down anymore, but 12 should. And so ultimately, I'm hoping to get another radical over here that has square root of 3 on it. So I'm going to go ahead and break down 12. I'm going to use the factor tree method. If you're not, you would still use 4 and 3. Notice. All right, so I'll have 2 and 2 as my group. So 12 itself is going to break down into 2 square roots of 3. Now I do need to be careful because I do have these extra coefficients here as well. So this 2 is coming on down, and then that square root of 12 turns into 2 square roots of 3. So this 2 came from here, and this came from breaking down 12. This part over here is just going to come straight down, so I'm going to leave that all the same as well, since it didn't simplify at all. All right, I'm going to multiply here. That's going to give me 4 square roots of 3 minus 2 square roots of 3. And now you can notice we do have that match that we were looking for. So I can combine those coefficients. 4 minus 2 is going to be 2. So 2 square roots of 3 is my final answer. All right, we have 3 terms over here. You can have negatives in the front. That's okay. It's going to kind of work like minus. But I have a square root of 5, a square root of 27, and a square root of 3. Neither 5 nor 3 are going to break down, but 27 should. You can kind of tell it's a bigger number, and if you're ever unsure, just go ahead and try to break it down in the first place and see if something will work for you. So we have 27. I'm going to break that into 9 and 3, and 9 should break into 3 and 3. So I have a group of 2 3s, so that will come on the outside. This lone 3 will get stuck on the inside. All right, so negative 2 square roots of 5 won't change for now. This 2 comes on down. All right, 3 square roots of 3 will happen right here from that square root of 27. And I didn't mess with this other part either. It's also just coming straight down. So I'm going to go ahead and multiply in the middle before I start combining my terms. So this comes down, 2 times 3 will make 6. And 3 square roots of 3 will come down at the end there too. Now notice not everything can combine here. So this term is actually just going to stay the same. I don't have any others that say square root of 5, but both of these have square root of 3. So I can put these 2 together even if I can't combine it with this. So this part will just drop down, and I can combine the 6 and the 3 to make 9. All right, and that makes this my final answer. All right, now on this one, 50 and 8 don't match, and both 50 and 8 can break down. Now again, I'm hoping to get those matching radicands once this happens. So let's see if that works. So if I break down 50, we'll go 25 and 2. 25 will break into 5 and 5. So that first chunk will be 5 square roots of 2. All right, the 8 is going to break down into 4 and 2. And then 2 and 2. So we'll have a 2 on the outside and a 2 on the inside, which looks like I am going to get the matching radicands that I need. On these ones, I don't have the number on the front. There are ones there, and if you want to make sure that you write those down just to make sure that you have them and get used to multiplying in the front of things, you can. Not totally necessary. So I'm going to go ahead and skip that part. But we have 5 square roots of 2. We'll keep that same sign. This is positive, so we have 2 square roots of 2 over here. And since these match, I can add these front numbers. 5 plus 2 will make 7. All right, other things that can happen. Here I do have another 2 pieces to simplify. And here I do have a negative 1. I am going to write that part down. So I'm going to break down 20. Let's see here. 4 and 5 will work. You could also do 2 and 10. Whatever you see first if you're doing factor trees. If you're using perfect squares, 4 and 5 would be the option that you need. So this part will be 2 square roots of 5. 6 shouldn't break down. If you're unsure, go ahead and break it apart. It's going to break into 2 and 3, which I can't do anything with anyway, so this part is ready to go. 24 does need to get split apart here. So on this one, I'll have 4 and 6. So 2, 2, and 2 and 3. All right, so do remember, here's my group of 2, and then I have a 2 and a 3 left on the inside, which will make 2 square roots of 6 here. Okay, so here, remember this negative 2 is coming straight down. Square root of 20 split into 2 square roots of 5. Okay, that's coming from right here. The 2 square root and the 6 in the middle didn't break down. Okay, that came from right here. Nothing we could do, so that's kind of stuck. All right, -1 is coming from this other problem right here, right there. Coming straight down. And then the square root of 24 will break into 2 square roots of 6. All right, so if I multiply, I'm gonna have -4 square roots of 5 plus 2 square roots of 6. And -1 times 2 will be -2, so -2 square roots of 6. All right, now if you do get something like 2 minus 2, that makes 0. So these two chunks actually cancel each other out. So you do get -4 square roots of 5. All right, here's the biggest one. Looks like 12, 18, and 27. None of them match, and all of them break down. So these ones do take the most work, unfortunately. 12 again, I think we broke this down already today, will kind of look like 2 square roots of 3 after we find our group of 2. 18 should be 9 and 2. So make 3 and 3, so it looks like 3 square roots of 2. And 27 will break into 9 and 3. 3 and 3, I think we broke this one down already today too. So we have 3 square roots of 3. All right, keep track, make sure that you have all the numbers that you need going on. So I have this -2 that was already part of my problem. Square root of 12 breaks into 2 square roots of 3. Right, the +2 is coming on down. 18 broke into 3 square roots of 2. This -2 came straight down. And 27 broke into 3 square roots of 3. All right, before I start combining anything, I need to multiply to get this down looking a little bit better here. So we have -4 square roots of 3 in the front, plus 6 square roots of 2 in the middle, minus 6 square roots of 3 back here on the end. All right, -4 minus 6 is going to make -10 square roots of 3. And I can't combine this chunk because it doesn't match. We have the square root of 2 there instead of the square root of 3. All right, and that makes this our final answer. All right, if you're feeling good about this, now's a great time to pause the video so that you can try this one. And if you're ready to check your answer, your final answer should end up being -11 square roots of 2.